Alright, air as a mixture. Air is a mixture of gases such as nitrogen, oxygen, carbon dioxide, noble gases, water vapor, and gaseous impurities in the atmosphere. So nitrogen consists about 78%, oxygen is 21%, carbon dioxide about 0.03, water vapor is variable, can be high or low, while noble gases such as helium, neon, and the rest 1%, and we also have impurities which can be sulfur oxides and the rest. So why is air a mixture? Okay, let's see the reasons why we call air a mixture. Number one, the constituents of air can be separated by physical means since they are not chemically combined. That is, with normal physical means such as heating and all the rest, they can be easily separated, okay, since they are not chemically combined in the first place. So that's why it's a mixture. It is not a compound, but a mixture. Now two, it cannot be separated, it cannot be represented by a chemical formula. Unlike sodium chloride, hydrogen chloride that have chemical formulas, compounds have chemical formulas, but mixtures don't have chemical formula. So this is another proof that air is a mixture. So three, the constituents still retain their individual properties. So normally, when compounds are formed, new properties are formed. So like a dangerous hydrogen combines with oxygen and produces water which we drink, you can see that a new property has been formed, but the constituents of air retain their individual properties since they don't react chemically together, right? So four, when the constituents of air are mixed together in their ratios, there is no evidence of chemical reaction like heat loss or anything. Okay, so when you are trying to form air, put all the constituents together, there is no evidence of any chemical reaction. Let's talk about nitrogen. So nitrogen consists of 78% of air. It is inactive and slows down combustion and corrosion. So combustion means burning, while corrosion means rusting. All right. So during thunderstorms, nitrogen combines with the oxygen in the air to form nitrates, and this can be deposited into the soil as useful nutrients for plants. Okay, it is a major ingredient. It is a major ingredient in proteins which are found in plants and animals. So nitrogen is a major ingredient in proteins. Let's talk about oxygen. Oxygen makes up 21% of air. It is the most active constituent of air and is responsible for corrosion, combustion, and even cellular respiration, that is our breathing. When substances burn in air, they form oxides, that is, they combine with oxygen when they burn in air. Like when carbon-containing substances burn in air, they form carbon dioxide. So when calcium burns in air, we have calcium oxide, and so on. So now let's talk about carbon dioxide. Carbon dioxide makes 0.03% of air. It is formed from combustion of carbon-containing substances. So the amount of carbon dioxide in the atmosphere is balanced by something called the carbon cycle. This tries to balance the amount of carbon dioxide released into the atmosphere, that is, during our breathing or other processes that carbon dioxide is released, with the amount absorbed, just like in photosynthesis where carbon dioxide is absorbed to make plants food. So it tries to balance the release and absorption of carbon dioxide. But this balance can be altered by excessive pollution through cars or industrial activities. So water vapor is in variable percentages. It can be high during cold seasons and low during dry seasons. Let's talk about noble gases. Noble gases make up 1% of air. So let's briefly look at the uses of different noble gases. Argon is used as gas in electric lamps. Helium, neon, and argon are used for decoration and advertisement lights. You must have seen this somewhere before. Krypton and xenon are used in cameras for taking high-speed pictures. Helium is safer in filling balloons compared to hydrogen, since it is very, very light and non-combustible, that is, they don't burn. Neon light is used in drones to see through fogs. Fog is that in very cold seasons when you see everywhere is white, covered up with water vapor, and you cannot see through. That's what we call fog. Now, radon is a radioactive element and is used in treatment of cancer. Separation of air components. Air components can be separated by fractional distillation. When liquid air is heated in a fractionating tower, the major constituents of air, such as oxygen and nitrogen, can be separated with their various boiling points. We have variation of composition of air. What is the reason for variation of composition of air? Although we have discussed the percentage of each component of air, this may vary due to pollution. For example, carbon dioxide in the air can increase due to excess pollution caused by vehicles. Water vapor can be less in dry season and much in cooler season. So although we have given you percentages, it can be altered. Okay, let's go to Jamb questions. So question 1 is from Jamb 1999. Which of the following will have its mass increase when heated in air? A. Helium, B. Magnesium, C. Copper pyrite, D. Glass. Okay, helium does not burn in air since a noble gas does not react with oxygen. So the correct answer likely is going to be B, because magnesium is a metal and burns with oxygen. So the answer is B. So question 2 is from Jamb 1999 also. Nitrogen obtained from liquefaction of air has a higher density than that obtained from nitrogen containing compounds because the former contains A. Water vapor, B. Oxygen, C. Carbon dioxide, and D. Rare gases. Okay, so the correct answer here is rare gases. So here is a similar question. In the experiment above, X is a mixture of nitrogen, carbon dioxide, and A. Water, B. Impurities, C. Inert gases, and D. Oxygen. So if you look at the diagram, air is passed through alkaline pyrogalol, which removes oxygen from air, and then it goes through anhydrous calcium chloride, which removes the water content. So what is going to be left? Nitrogen, carbon dioxide, and the inert gases. Okay, so inert gases is a more correct answer than impurities, okay, since it is in larger quantity. Now we have another one from 2004. Which of the following mixtures of gases is likely to burn in flame? A. Neon and hydrogen, B. Nitrogen and helium, C. Helium and neon, D. Neon and nitrogen. Now remember, nitrogen slows down combustion, that is, it tends to prevent combustion. So any option with nitrogen should be striked out, that is option B and D should be striked out. Now we have A and C left. Remember, C has helium and neon, so both of them are noble gases and will not combine with oxygen, so that is also striked out. So the answer is going to be A, neon and hydrogen, because hydrogen can burn, that is combine with oxygen. Alright, so the correct answer is A. Now we have another question from 2013. The constituent of air that acts as a diluent, that it tends to make other things inactive, reduces the effect of other things. A. Nitrogen, B. Carbon dioxide, C. Noble gases, and D. Oxygen. The correct answer is nitrogen. So nitrogen is very inactive and acts as a diluent. Thanks for watching. If you are new here, my name is Wisdom Richmond, and don't forget to like, share, and subscribe for more videos like this. God bless.